In this video, let's learn about how to use the light sensor, specifically the photoresistor. So photoresistor is a light sensitive resistor. If you shine light on it, its resistance decreases. If you keep it in the dark, its resistance increases. Because when you shine light, more electrons get kicked out and become free to conduct. Therefore, the resistance decreases. I'm also going to import an Arduino, and here it is. Okay. Now let's zoom on this a little bit so that it's visible a little bit better. Okay. The way to use an light sensor is using a resistor in series concept. So let's import a resistor also. Here it is. And it's going to ask me the value of the resistor, and I want to use 10 kilo ohm. And the color is going to change accordingly for the 10 kilo ohm resistance. So you connect one end of your light sensor to the 5 volt on Arduino. 5 volt is like a battery power source, and the ground is a negative terminal of the battery. And the other end of that wire is going to go to the other resistor. So the positive and negative of the battery. And the usual resistor and the photoresistor are now going to be connected in series by having another wire go from here to here. Okay, this is my resistance series circuit. Positive voltage comes here. Let's mark that with a positive color, and then goes through the current goes from 5 volt, goes to the photoresistor, passes through this line, and then goes to the other resistor 10 kilo ohm, and then goes back to the ground. And let's mark the ground with where is my brown color? There we go. Okay, now the voltage here at this location is 5 volt, and the voltage on ground by default is 0. That's how we call the ground, 0 voltage. So this whole red line is 5 volt, this whole brown line is 0 volt, this green line is in between 5 and 0. And how much is it exactly? That depends on the ratio of the two resistances. So using the logic of resistors in series, the voltage decreases from 5 from here to some value and back to 0. And the current flows from 5 to 0. And this line, the green line, has a voltage which depends upon the ratio of the resistances. So as you shine light on the photoresistor, the resistance value changes, the ratio of the resistors changes, so the voltage on the green line changes. So if we can somehow measure the voltage on this green line, then we can estimate how much light is falling from it. So I'm going to connect this green line using these pins on Arduino, which are specially geared towards measuring voltage, especially the voltage which is not 0 or 5, but anywhere between 0 and 5. And those are these analog pins, and I'm going to use the analog pin A1 to measure the voltage between 0 and 5 somewhere. Okay, the connections are complete. Now let's look into our code, and I want to go for the text code option. Okay, so pin number A1 is being used over here, and we'll be measuring voltage in from the pin number A1. So I'm going to use pin number A1 in the input modality because I'm measuring voltage in over here. And this, the command to read the value would be analog read. Remember the digital read command that can read the voltages on pin number 0 to 13, but can only read either 0 or 5. But analog read, which only works on pin number A0 to A5, can read any voltage between 0 and 5. So I'm going to say analog read, and the pin number is A1, and then whatever is the voltage on this pin number, that would be reported as a number, and I need to store it in a variable. Let's call that variable light. Okay, and if you want to use a variable, you have to define a variable. So I'm going to define an integer variable, and the name of that integer variable is light. Okay, the code is complete, but it would be really nice for us to see what the actual value on the light is. So we're going to print that value, and we're going to use a command serial dot print in a new line every time the loop runs. So we're going to print the variable light using serial dot print. And if you want to use a serial dot print, you have to of course use the serial dot begin first. And since that needs to be done only once, we can put that inside the setup function. Okay, the coding is complete. And remember, remember all the capitalization. M is capital, S is capital, and input is capital, and so on and so forth. Okay, start simulation. Hopefully there are no errors. Great. Click on the serial monitor. And this right here is the number which corresponds to what the value is being read by the analog read command on pin number A1. And you can actually change the light. And as you change this light, this value changes. So this value goes to a high number of 974, and the lowest number it goes to is about 54. And that's what, and this, now this number over here is actually a conversion of the voltage from the actual voltage to a number between 0 and 1023. So when the voltage at this green line is 0, A1 pin would give you a 0, and that's what would be stored in the light. And if the voltage on this green line is 5 volt, then A1 pin will read 1023. So as the voltage on pin number A1 goes from 0 to 5, the values read by it and stored in the light variable will go from 0 to 1023. So this number actually corresponds to the voltage, but the conversion is 0 to 5 volts is 0 to 1023. All right, and this is how we can do a light sensor.